The entire fire service is dedicated to saving lives and property. In a rescue incident, the firefighter is faced with a victim in a life-threatening situation. In such cases, firefighters must be thoroughly trained in proper rescue techniques and equipment. In this program, you will see several rescue techniques, as well as the proper use and care of various rescue and extrication tools. The learning objectives are to demonstrate how to move injured victims using carries and drags, to present the use of various types of rescue tools, to describe the dangers of vehicle components and systems, and to demonstrate how to extricate a victim trapped in a car. Firefighters need to know how to quickly and safely move injured victims away from hazardous situations. Using the proper drag or carry will enable the rescuer to move an injured or unconscious victim to a safe place. If one rescuer must carry a child or very small adult victim alone, the cradle and arms lift and carry is often successful. Place one arm under the victim's arms and across the back. Place the other arm under the victim's knees. Keeping your back straight, lift the victim to about waist high. Carry the victim to safety. Another option for a lone rescuer is to use a blanket or large coat to drag the victim to safety. Place the coat or blanket beside the face-up victim, making sure the blanket extends above the victim's head. Kneel on one side of the victim and gather one edge of the blanket or coat close to the victim's opposite side. Extend the arm nearest you above the victim's head. Roll the victim toward you and gather the coat or blanket underneath. Roll the victim back onto the coat or blanket and straighten the blanket on both sides. Wrap the blanket around the victim. Grasp the coat or blanket at the victim's head and lift enough to clear the head and shoulders off the floor. In this manner, drag the victim to safety. If two rescuers are available to move a victim, the extremities carry may be used. One rescuer kneels at the head of the victim, and the second rescuer stands between the victim's legs. The rescuer at the head supports the victim's head and neck with one hand and shoulders with the other hand. The rescuer at the victim's legs pulls the victim by the wrist to a sitting position. The rescuer at the head reaches under the victim's arms and takes the victim's wrists from the other rescuer, taking opposite wrists and crossing the victim's arms against the chest. The firefighter at the legs then turns around and slips his hands under the victim's knees. On command from the firefighter at the victim's head, both firefighters stand and carry the victim. To effectively perform rescue and extrication procedures, firefighters must be trained in the proper use and care of rescue tools. You must know what kinds of rescue tools your department carries and the capabilities of each tool. Commonly used rescue tools include cribbing, hydraulic tools, pneumatic or air-powered tools, and lifting or pulling tools. Cribbing consists of blocks of specially selected wood or plastic materials and is commonly used to stabilize objects. Rescue vehicles should carry an adequate amount of appropriately sized cribbing. The ends of the blocks may have holes cut in the end, with a rope loop tied in the holes for easy carrying. Cribbing can be stored by stacking in compartments with the grab handles facing out for easy access. Storage crates make transporting several pieces of cribbing easier. Cribbing made of plastic is more expensive than wood cribbing, but it has the advantage of not absorbing fuel and other substances and lasts longer than wood cribbing. Powered hydraulic tools receive their power from fluid pumped through special hoses. Hydraulic tools can be powered by electric motors, gasoline engines, or by hydraulic pumps powered by vehicle-mounted power takeoff systems. Either type of power supply may be designed to carry with the tool or may be mounted on the vehicle. There are 4 basic types of powered hydraulic tools used in the rescue service: spreaders, shears, combination spreader shears, and extension rams. Hydraulic spreaders are useful for a variety of different operations involving either pushing or pulling. The tips of the tool can produce tons or many kilonewtons of spreading force. The tips on some models spread as much as 32 inches or 800 millimeters apart. Hydraulic shears are capable of cutting almost any metal object that can fit between the blades. They may also be used to cut other materials, such as plastics or wood. Shears are capable of delivering up to about 100 tons or 900 kilonewtons of cutting force and have an opening spread of up to about 7 inches or 180 millimeters. A combination spreader shears tool consists of 2 arms equipped with spreader tips, with cutting shears on the insides of the arms. Although combination spreader shears are not as powerful as the individual units, they are a cost-effective alternative in many cases. Extension rams were designed primarily for straight pushing operations, but may be used for pulling, shoring, stabilizing, and supporting objects during rescue situations as well. The extension rams open to an extended length of about 5.5 feet or about 1.5 meters, which is helpful when objects must be pushed farther than the opening distance of the spreader. Manual hydraulic tools are powered using a pump lever rather than an external power source. The hydraulic jack is good for most heavy lifting situations and for shoring or stabilizing operations. The Porta-Power tool system is an auto body shop tool that has been adapted for use in rescue operations. The primary advantage of the Porta-Power tool is that it has a wide range of accessories that allow it to be used in very narrow places where a hydraulic jack couldn't fit. The primary disadvantage of this tool is that it is time-consuming to assemble and operate. When using any type of jack, adequate blocking and cribbing should be used. Always wait until the cribbing is firmly in place before getting under a load supported by a jack. Pneumatic tools use the energy created by the release of compressed air for power. Air chisels, air hammers, and air wrenches are useful for extrication work. Air chisels or hammers are good for cutting through medium to heavy gauge sheet metal and for popping rivets and bolts. In areas containing hazardous or flammable atmospheres, pneumatic chisels should only be used with extreme caution. The sparks produced during cutting may provide an ignition source for flammable vapors. Pneumatic wrenches are useful for situations where the best way to remove a vehicle part is to disassemble it. Air lifting bags give rescuers the ability to lift or displace objects that cannot be lifted with standard extrication equipment. Airlifting bags come in 3 different types: high pressure, medium pressure, and low pressure. Low and medium pressure bags are larger than high pressure airlifting bags. Be sure to use the proper bag for each rescue situation. No more than 2 bags should be stacked, with the smaller bag on top. Inflate the bottom bag first. Inflate bags slowly while monitoring the load for shifting. The load is constantly shored up with cribbing in case of shifting or bag failure. Remember the rule of thumb: lift an inch, crib an inch. The firefighter running the bags and the firefighter doing the shoring should stay in constant contact in case evasive action is necessary. Other lifting or pulling tools frequently used in rescue include winches, come-alongs, chains, and block and tackle. Vehicle-mounted winches can be deployed more quickly and have a greater pulling distance than other rescue pulling devices. A come-along is a portable cable winch attached to a secure anchor point. A cable is run out to the object to be moved and is reeled toward the anchor point by operating a manual ratchet lever. Both winches and come-alongs can be used in combination with chains to create a lifting or pulling system. Chains used in rescue are made of alloy steel to resist abrasion. A block and tackle is another useful tool for lifting or pulling heavy loads. A block is a wooden or metal frame containing one or more pulleys called sheaves. The tackle is the assembly of ropes and blocks that the line passes through to multiply the pulling force. Vehicle manufacturers are constantly improving the safety, economy, and luxury of vehicles on the road. But many of these systems can become significant hazards to rescuers after an accident. To safely extricate victims, rescuers must become familiar with the systems and components of new vehicles on the highways. In this program, we'll describe 5 common hazard areas in vehicles: airbags and automatic roll bars, electrical systems, oil and air-filled struts and bumpers, fuel systems, and tires. Passenger restraint systems, or airbags, have increased the survival rates of vehicle accidents, but they can seriously injure rescuers if they accidentally deploy after an accident. There are 2 types of airbag systems: supplemental restraint systems, or SRS, which protect from a head-on collision, and side impact protection systems, or SIPS, which protect victims from a collision on the side of the vehicle. Both types of airbags deploy at speeds up to 200 miles or 322 kilometers per hour with immense force. An electrically operated restraint system is powered by the vehicle's battery and is activated when sensors on the vehicle are triggered. These systems have a reserve energy supply that can deploy the airbag up to 30 minutes after the battery has been destroyed or disconnected. Especially during extrication operations, all rescue personnel should wear personal protective clothing, including hand and eye protection, and exercise extreme caution when working in vehicles with automatic restraint systems.
How about up here in your head?
Some convertibles have automatic roll bar systems designed to be inconspicuous. Roll bar systems deploy when sensors detect that one or more of the vehicle's wheels have lost ground contact. If roll bars deploy when rescuers are working around them, they can injure the rescuers and the patient. Before beginning extrication, a member of the team should scan the passenger compartment for airbags and roll bar systems and report their locations to the officer in charge. Airbags can be installed in many areas of the passenger compartment. The most common locations are the steering wheel, dash, seat backs, doors, and overhead rails. On many vehicles, the best way to prevent the accidental deployment of passive restraint systems is to turn off the ignition switch and disconnect both battery cables. Always disconnect the negative cable first, then disconnect the positive cable, avoiding any contact with exposed wires. Wait for the reserve power supply to drain down. Some vehicles have a switch that disables the passenger side airbag. However, the driver's side airbag remains operative. Side impact airbags sometimes are mechanically operated and do not require electrical power to deploy. To completely disarm the system, the connection between the sensor and the airbag must be broken. It may be impossible to prevent accidental deployment before rescue operations must begin. In these situations, keep in mind the danger that airbags pose, and do not place yourself or your equipment in the inflation zone. A good guideline to practice to avoid inflation zones of most airbags is the 5, 10, 20-inch rule. Firefighters using the metric may learn it as the 13, 25, 50 centimeter rule. Generally, stay 5 inches or 13 centimeters away from side airbags. Stay 10 inches or 25 centimeters away from driver frontal airbags. And allow at least 20 inches or 50 centimeters for passenger frontal airbags. Electrical shock is another significant hazard of vehicle systems. This is a risk in any vehicle, but especially in hybrid vehicles, which have both a 12-volt battery and a high-voltage system. Approach a hybrid vehicle the same as a conventional vehicle, but beware that the car may be on even though there is no engine noise. To shut off the vehicle, move the gear shift to the park position. Turning off the ignition cuts power from both the 12-volt and high-voltage system. If you do not see an ignition key in a vehicle, it may have a wireless smart key system that allows drivers to start the vehicle without removing a key fob from their pocket or purse. To shut down the power on a vehicle with a smart key system, push the power button on the dashboard once. Check the lights to make sure the power is off. If the ignition system is not accessible, you may disconnect both electrical systems by cutting power from the 12-volt battery the same way you would in other vehicles. In most hybrid vehicles, bright orange cables and enclosures identify the second high-voltage system. To avoid serious injury or death, always use extra care to avoid touching or cutting any high-voltage cables or components. Additional hazardous components of vehicles that must be assessed before beginning extrication include fuel systems, oil and air-filled struts, and tires. Determine what type of fuel is involved and check for leaks and possible ignition or explosion. Oil and air-filled struts for hoods, trunk lids, and bumpers can become dangerous projectiles if heated. Stay away from bumpers and cool these components as soon as possible. Tires may also explode when heated because of the air pressure. Follow department protocols for deflating tires to minimize this risk. One of the most frequently encountered rescue situations involves extricating a trapped victim from a car. Proper accident scene size-up is crucial to performing an extrication procedure. One or more rescuers should survey the accident site and determine how many vehicles are involved and any potential hazards at the scene.
I'm going to have you do the inner circle.
Someone trained in first aid or advanced emergency medical care should assess and triage the victims and the extent of their entrapment. A scene size-up should be given to the incident commander, indicating the number of vehicles, hazards at the accident scene, and the number and condition of the victims. Following scene size-up, rescuers must stabilize the vehicle. Even if a vehicle is in an upright position, it should be secured to provide maximum stability for extrication operations. Do not rely on mechanical systems, such as parking brakes, as the sole source of stabilization. The vehicle should be stabilized with cribbing to prevent both horizontal and vertical movement. Chock the wheels to prevent horizontal movement. Jacks, airlifting bags, and cribbing are often used to prevent vertical movement during extrication. When using any of these methods, put the stabilizing device in place without putting your hands or other body parts under the vehicle. There is always the possibility that the car may drop unexpectedly. Breaking glass.
There are three basic methods of gaining access to a trapped patient: through a normally operating car door, through a car window, or by opening up the body of the vehicle. Rescuers should choose the easiest route available to gain access to a vehicle. Once access to the vehicle is gained, at least one rescuer with appropriate emergency medical training should be placed in the vehicle to attend to the patient. If a patient has sustained substantial injuries, the vehicle should be removed from around the patient, rather than just pulling the patient from the vehicle.
Up here in your head. Go down your
The situation should be assessed with the patient's safety foremost in the rescuer's mind. The roof of the vehicle is often removed in order to extricate the patient. This can be accomplished by either cutting all the roof posts and removing it entirely, or by cutting only the front posts and cutting relief notches in the top of rear door openings and folding the roof back over the trunk. Doors can be opened from the handle side or removed completely by inserting the rescue tool in the crack on the hinge side.
Camera's rolling.
Often, the patient is trapped by the steering wheel or the dashboard. If a patient is trapped by the steering wheel, your initial actions might be to locate and operate the steering wheel tilt control. If this slight movement of the steering wheel is not enough to free the patient, try moving the seat back. If these actions don't work, you may need to use more advanced procedures, such as cutting the steering wheel. Be sure to fully shut down the vehicle's electrical system before beginning these procedures. Avoid positioning cutting tools in front or over the airbag deployment zone, or placing them in the patient care area. Make 2 cuts to the lower portion of the steering wheel and remove a section. Or make 1 cut in the lower left portion of the steering wheel and bend it up and away from the patient. Another way to free the patient from the steering column is called lifting a length of chain. To perform this technique, place reinforcement cribbing on the hood near the firewall. Then attach a long length of chain or strap securely to the front end of the vehicle. Run the chain or strap across the hood and attach it directly to the steering column. Place a lifting tool, such as a high lift jack, on the cribbing with the lifting portion of the tool under the chain. Operate the tool to lift the chain or strap, pulling the steering column up and away from the patient. The dashboard displacement method can be used on vehicles with front-wheel drive. This is accomplished by making cuts in the bottom of the front posts, also called the A-posts. An extension ram or jack is placed in the doorway to roll the dashboard forward. Cribbing inserted under the base of the A-post on unibody vehicles or between the frame and the body on full-frame vehicles prevents the dashboard from returning to its original position. Once the path has been cleared and the patient has been properly prepared for removal, any sharp edges should be covered to prevent injury to rescuers and the victim.
On 3. 1, 2, 3.
Rescue and extrication are common fire service response calls. In this program, we have shown you some basic rescue techniques and shown you various rescue and extrication tools. You have seen how to move an injured victim using carries and drags, various types of rescue tools, the dangers posed by vehicle components and systems, and how to extricate a victim trapped in a car. When the public calls the fire service for help, they expect a highly trained, experienced responder. It is up to us to meet and even exceed those expectations.